Hello, hello. Welcome to my session. Today I'll be talking about encryption algorithms and how we can use it and how we can use it in Java. So Java has very good support for encryption algorithms. So we'll be exploring how we can take advantage of those mechanisms. Um, okay, let me introduce myself quickly. My name is Nadir, and this is my third Global Hack Week in total. So I first started streaming in April when we had the Global Hack Week API. And then I liked the experience very much. And I decided to host more sessions in the next month event, which was about games. And so continuing that excitement today, I'm joining once again to stream about uh, encryption algorithms. So let me post a link where people can join, register and join. Okay. So if you are still not registered, please register yourself and also please leave a comment so I know that you are able to hear my voice loud and clear. Hello. I'm gonna wait 1 more minute maybe until everyone who's interested in our session to join. Yes, okay. There are questions about if I can speak louder. Yes, I can speak louder. Um, okay. I'll wait a little bit more, okay, until people's join. Oh, thank you. Thanks. I don't know if I like my voice in real life, but thanks. So the question, are we going to it? Are we gonna do it locally or on Replit? So I prefer Replit because I don't have to set up many things on my local machine. So Replit comes with um, all the tools necessary for me to write code and compile and execute. Yeah. Okay. I think we can get started. Um, so, so uh, just wanted to understand if anyone have heard about encryption before. Um, do we know why we need encryption? Yeah. Why do we care about encryption? Can you give me your answers, please? Why do we need encryption? We can we live without encryption? Yeah, leave your comments, please. If you if you have any opinions. Yes. To protect privacy. Okay, yes, yeah, that's totally true. We want our data to be protected from from uh, from other people. So we want that data to be available to us and people who 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 we want to share with, but not other people. So we want to maintain privacy, and we need to hide our data somehow to communicate our data securely to other people, right? Um, yeah, to protect us. Exactly. That's the one of the major goals of encryption, to protect the secrecy of data, right? To maintain confidentiality. Yeah, data confidential. Yeah, that's also true. Yeah. So one of the use cases of encryption uh, could be pay um, when we pay for our purchases over the internet, right? So when we mm, add items to our shopping basket and we want to pay to check out items from our basket, then we send sometimes we send um, our PayPal information, or most of the times probably we send our card information, such as 16-digit card number, and we want that information to be communicated to merchant in a secure manner, because internet is as we know, not a secure place. So there are many security mechanisms developed to protect the secrecy of our data, where we send our data. We want to make sure that the data reach the destination uh, intact, meaning it's not tampered, it's not modified along the way. So we want to encrypt it before we send it. And so once we encrypt our data, let's say once we encrypt our card information, right, and send it to merchants so they can charge us, merchant has to read that data so they can charge us correctly, right? So besides encryption, there is a process called decryption. So this is opposite of encryption. So decryption takes basically data that arrived from the internet and makes it legible, readable for the merchant. Okay. So basically, when we send data, we scramble data so it becomes uh, illegible, meaning uh, it becomes meaningless, right? And then when our data reach to destination, that meaningless information has to be decrypted to become meaningful again. Okay. So there are two main types of encryption used in industry. So not if you've heard about um, uh, so the two main types of encryptions are called uh, so, private key encryption, also known as symmetric key encryption. This is when uh, when we want to encrypt the data and decrypt the data, right? We use the same key for both operations, because when we do encryption and decryption of data, we usually use keys. So the uh, so keys are like keys to our locks, right? So before we send data, we want to lock it. We want to use a padlock, for example, and use our key to lock it. And at the destination, we use the same key to unlock it. So this is an analogy that we can use to understand the concept, right? So uh, I have some images here to explain. Uh, so so I've taken this image from internet. So I just typed public key versus private key encryption. I'm just using one of the images that came up from the result. So private key encryption, as you see, so we have two parties involved, right? So we have a sender who wants to send data, and we have recipient who wants to receive that very same data. And as you see, sender has data that has meaning, right? It's plain text information. So human or a machine can read that data and act on it, right? So that's useful information, meaningful information. But before sender sends that meaningful information to recipient, so that needs to be encrypted. As you see in the image, in private key encryption, only one key is used for encryption and for decryption, right? So once the data is encrypted, uh, it becomes data becomes unreadable or meaningful. I mean meaningless, and to decrypt that information, we use the same key, and then suddenly, once this decryption is over, that data becomes meaningful again, right? So let me show it, show the process. Okay, so I'm gonna create just a quick a Replit project. Global quick security. So let me create a text file. Right. So let's say we have data, we have a message, right? We want to send to our friend, right? And the message reads, "Hello, my friends," right? And so when we do, when we go through this process, right? So we want to use private key encryption, and we want to use key to encrypt, and then use the same key to decrypt the message, right? So when we do encryption, right? So when we do encryption, the message becomes that very same message, which reads, "Hello, my friend," becomes something like scrambled. As you see, this is something meaningless, right? So we cannot look at this information, this data, and say, this means something useful. No, we cannot say that. So once this data is, once we have this encrypted data, we cannot actually read it. We cannot extract meaning from it without decrypting it first. So when we decrypt the message, we again get back our hello, my friend information. So this is sender encrypts this, and the message becomes scrambled, and then once the scrambled message is decrypted, it becomes meaningful again. Okay, so this is the process. And yeah, this is called symmetric, also known as symmetric key, because same key is used for encrypting and decrypting. I like to use name private key encryption because keys are not announced to other people, and that key is kept in secret, in private, between sender and receiver. Okay, so this is a little bit of theory. Can we? There is a question. Can we follow along using that link? Which link do you mean exactly? You mean, okay. That link actually registers you to the session, so you can. Oh, the replets. Okay. No, you can open your own replit project, and so this is theory section, right? I'm gonna give you some theory behind encryption, and we also have coding session where we actually code uh, using Java. We will take one sample message, encrypt and decrypt it, and see how it works. Okay. So that was about private key encryption, and there's second type of encryption that's very common in industry is called public key encryption. So the first one was private key encryption, which we have just seen, right? And so that was this process, right? Sender, receiver, and they use the same key. So this is private key. And for public key, things look a bit different. So for public key encryption, sender usually has not one but two keys. Okay. So one key is used for encryption, and the other key is used for decryption. Okay. So the process is not that simple as it looks in the picture, but I can explain it using analogy. So imagine, for example, you have a lock, a padlock, and a key, right? So a key to that padlock, right? So that key can open and lock and unlock that padlock. So we are familiar with that analogy, right? So we have seen it many times in our life, and now you can think of padlock as a public part of the key, and the real key which we use to open that padlock as a private part of the key. So we tell everyone that, hey, if you want to send me any data, you can use my lock and put your data inside that lock and lock it and send it to me. And because the data is locked using our padlock, right? And it's us who has the key only, and no one else has it. So that means that it's us who can only open that padlock to read the data. Okay, because we have private key to open our padlock. No one else has it. So that's why we have public key and private key components. So as you see in the picture, so plain text is encrypted using public key of the recipient, right? And so because a public key is announced to everybody, so everyone knows recipient's public key, it's open. So anyone who wants to send the data to recipient, they use the recipient's public key to lock, to encrypt the plain text. And then once the scrambled message arrives to the recipient, only recipient can unlock it or use their private key to decrypt it. No one else cannot. No one else can do it. Okay. The process may be a bit complicated, but this is how e-commerce works. Okay. So if you purchase an item over e-commerce websites like Amazon.com, you can see that this process is taking place behind the scenes. It's not obvious, people don't see it, but this is basically what happens. Okay, so they use a combination of public key and private key encryptions to securely communicate. All right, that should be enough of theory, right? Okay, let me see the comments. Yeah, it's a cryptography part. It's actually very simplified explanation. When I've taken my cryptography class about 10 years ago, so we had to learn discrete math because it's very math intensive, and the subject requires a good understanding of number theory. Okay, especially prime factorization, because the strength of public key encryption comes from factorization. It may be you may think that factorizing a number is easy. Yes, it is easy, but when that number is really, really large, factorization, factorizing that number into prime numbers is very, very difficult and requires lots of computing resources. That's where the strength of public key encryption comes because of this difficulty. Yeah, RSA, which someone mentioned in the chat, that is an example of public key encryption, and it was invented, I think, in 1970s, somewhere, yeah, it's like a long time ago. but we extensively use it. uh, okay. Uh, yeah, padlock emoji is missing. Do we have it actually? That would be really cool. Keyhole. Yeah, yeah, that's a very good explanation. Someone wrote here, reminds me of a combination lock. Yes. That's what I imagine in my head before I try to understand the concept. Yeah. Okay. Yeah. So I think we have some understanding of private key encryption, public key encryption, and now I'd like to. So we've covered like spent half an hour for theory, and now practical parts. And I wanted to show how we can actually use encryption algorithms in Java to encrypt and decrypt data. Initially, I thought about writing our own encryption algorithms, but Java already has very good support for both private key and public key encryption. And I thought maybe we do a little bit of pivoting and then use Java's solution, actually see how we can encrypt and decrypt the messages. Okay. Okay. Let me go and write. I can close this. So we're going to use Replit, okay, to create a project where we, for example, take hello world message and then encrypt it, and we attempt to decrypt it again. So I don't need this main.java. I can delete that. Delete the file. I'm going to create my own. All right. So let me check the comments before I start coding. Okay. All right. Okay. So I see we're ready for coding, right? Exciting part of the session. Okay. I'm gonna use. So just before I create my files and start coding, just another piece of theory. So we're gonna first cover private key encryption. Okay. So private key encryption is extensively used at the same level as public key encryption, and over the years there were many algorithms developed for private key encryption. So one of them was called DES, meaning like data encryption standard, I think. Standards. So this is like a well-known algorithm that is used for private key encryption, and it had a key length of 56 bits. So 56 bits might be secure enough many years ago, many decades ago, but it's not at this time. So this can be brute forced easily by machines of our age, right, of our time. Uh, so once key is known to the hacker, then they can decrypt the message easily. Um, so that's not secure enough. That's why another algorithm was invented. It's called AES. So I think it's called Advanced Encryption Standards. Correct me if I'm wrong with the acronyms, please. And I think it starts with 128 bits of key, and it can go to 256, 512, and 124 and 248. So I think standard way of usage now on internet is using this 248 bits of key using AES, and breaking this encryption algorithm technically impossible. Technically impossible with current machines, because it may take centuries, like many thousands of centuries to um, uh, break this algorithm that uses 2048 bits of keys, for example. So that is yes, 192 is also correct. Yeah, I've seen that length also. Um, yeah. All right. So for today's session, we're gonna use AES. Okay. So AES is a private key encryption algorithm, as we mentioned, and I'm gonna use that AES to encrypt and decrypt our sample data. So I'm gonna create a file called AES test. Okay. .java. Uh, uh, okay. Um, right. So, okay. Public class AES test. Um, so, so I'm gonna create standard way of standard set of standard methods to start our Java project. Static void main. So we need this method so the virtual machine can actually start our Java project. So Java projects need this main method. This is the entry point to our Java program. So before we actually create and use a private key encryption algorithm, we need to first create key, because we need to first generate the key and then use that key to encrypt and decrypt. Okay. Um, so for the purpose of key, generating keys, I will use Java's packages. So Java comes with very good support for uh, for security in general. Security is built in to Java. So we're gonna use first IO package, because we're gonna use file input stream and file output stream to actually read data from file system and read data to file system. So we need that package, and we also need Java security package, because we need key generator class, and we also need Java. What was it? Crypto. Okay. Then the class path project. Okay. So let's quickly check if our class works fine. Okay, let's run. Let's pass one error. Import. Okay. Or should I rename it to main? It's not sure why it's complaining. Package crypto does not exist. Okay. Okay. I think I know the reason, because crypto is not in Java package but in extension package, right? Okay. Okay, let's run it. Okay, good. We have this printed. We can proceed. Let's get rid of this. Let me quickly see the comments. No comments. Okay, that means you are with me, right? Right? Okay. Right. Great. Yeah, thanks. Thanks for support. Right. Okay. So as I said, first we need to generate key before we actually use the encryption algorithms. So we have key generator class that comes built in with Java. So key generator class is important one, because It is the class which we use to generate our private key. So our private key is used for um, if, private key is used in our private key algorithm, encryption algorithm. Okay, so yeah, to encrypt, so we need to generate a key, um, and uh, and we also need to make sure that that key we use in our algorithm is generated randomly. Okay, because we don't want hackers to generate those keys uh, easily, because when we introduce randomization, that significantly complicates the chances of figuring out the key by bad actors. Okay, um, so how do we generate the key? Once again, we have the key generator class, and we create an object of this class, and to actually assign to to actually create an object, we use key generators get instance method. Okay, so get instance returns one single instance of the key generator. So we don't have to worry about provider, but we need to specify the algorithm here. So as you see the description, so get instance method, it requires an algorithm. So which algorithm do we use? As you might have guessed, we use AES, right? So this is the algorithm we want to use. Um, um, as I mentioned, we also want to use randomization when we generate our key, because randomization, as I mentioned, it introduces, it significantly complicates the figuring out the key by bad actors. So we can. So Java comes with several ways to generate random numbers. So one way would be to use random class, right? Random class. But do we know the risk behind this method? Can anyone guess? Mm, uh, yeah, random. So yeah, we have random class which generates a number in Java, but the problem is it's a pseudo-random number generator, right? And when we use this pseudo-random number generators, it's predictable to some extent. The numbers generated by this random class is not secure enough, does not meet our requirement, and that's why we use secure random, this class, secure random. Okay, so secure random can create a random object and secure. Secure. So once we created a random object, right? We can initialize our key generator using this random object. So the key generator, we need, before we actually use our keys, we need to initialize it. Okay, key size, which inch? Yep, this is the correct signature we need to use. Key generator, and we initialize the random. We initialize the key generator using randomizer. Okay, and so what kind of key we need to generate? If we go back to our image here, right? So we need to generate something called shared secret key that encrypts as well as decrypts the data, right? So we need to generate only one key here. So Java has secret key class. Okay. So as you see the description of the secret key, it says a secret symmetric key. The purpose of this interface is to group all key. Basically, this interface is used for secret key, this or symmetric key, which we need for our session. Secret key, and so we create a variable of type secret key, and then we assign an actual key to that variable. So we already have key generator, right, created, and then key generator we can call generate key to actually assign a key. So now we have a key here. So we can, what we can do is we can try to write this key to a file so we can observe, see what it looks like, right? Okay, so we want, I'm going to use this package, IO package, because I want to use file output stream to write the key to a file, so we can see it how it looks. Okay, so I'm going to use a try with resources. So Java has a construct called try with resources. Once we open the resource, we want to make sure that it's closed correctly. So we can ensure this using try with resources construct. So so we create object output stream, and inside our object output stream we use file output stream, and so we're gonna pass So we're gonna pass the file name using arguments. So that's why we have this. So arguments, we access it using indexes like this, and we use out write object key. Okay, something is wrong. There's not 0.7. Resource specification is not allowed here for source level below 1.7. I think we need to change the source level here. Settings. I think we need to change the Java okay. Do we need to change the Java's version here? Why it's complaining? Not really sure. Source specification is not allowed. Okay, it's me. Okay. Files. Okay. Okay. Or should I throw an exception here? Let me throw your exception. Just trying to see if it's because of the class not found exception or general security exception. Is it still complaining? Okay. Anyone has an idea why we're having this? Okay. Resource specification not allowed here for resource for source level below 1.7. Toggle on. Okay, we can try without try with the resources. Try. Exception. Okay. Okay, we just okay. Let's try to run our no such algorithm exception. Unreported exception. Okay. Or maybe I will just general security. Let me try this. General security exception. Okay. Array index out of bounds. Main Java 11. Yes. Okay, let's try with console. Java C. Okay. Java C and gonna use a file called our key. Let's try. So now, as you see, key has been generated here. So we're gonna use this key to encrypt our algorithm. Encrypt our data. So as you see, we have created secret key, and so this key is stored in a file called our key, and this key is not readable, which is what we want, and it's randomly generated, and it should be ready for use for encryption purposes. So I can see we already covered 1 hour of our session. So at this point, I suggest we take 5 minutes of break, and we come back here in 5 minutes, and we use this our file called our key, which represents a shared key to actually encrypt and decrypt the message using AES, Advanced Encryption Standard Algorithm. Okay. So let's take a 5-minute break, and I'll see you in 5 minutes. Hello, everyone. I'm back. Okay. I see there are comments left just before we've wrapped up the first part. Uh, Compiler problem. One comment reads, no, I'm not really sure why it complained. We are using Replit, so could be Replit problem. Mm, um, can you go back to your main class? Yes, this is my main class. As you can see, there are um, okay. Can you share your Replit Nix file? Can we share it actually? I wasn't aware of that. Yeah, definitely. If I can share, I will. Um, the main class is not working right now. Never mind. Got it. Okay. The main class, for me, it's compiling and working. Do you have the exact same syntax? Mm, okay. Yeah, I will share. I will share the files once session is over. Okay. Um, so I'll communicate that on Discord channel, so everyone is aware of where the files are shared. Uh, mm, right, because when you run the main, because we need to pass an argument, right? Because we are explicitly asking for zeros index in the argument. So we're gonna use, so in the console, if we use just Java, Java main, then yeah, we get index out of bounds because we are missing here an argument. So we need to pass an argument like my new key or something like that. Okay, so it generates the key here. All right. So we've created a key. Now we want to use this key to encrypt and decrypt. Key generator. Okay. Mm-hmm. Right. Yeah. I will take a look at it. Um, is it the replit? Okay. I'll see it after the session. Uh, okay. So once we have our keys, we want to use that key to actually encrypt the message. So, so let's say when we run the so what is the command to directly generate the key again? So once again, my command is, so I use Java, I call main class, and then I pass the name, file name, which is called my new key. You can call it whatever you like. Uh, and we need to pass this because our program expects this my new key argument. Okay. Mm, yeah. So from the console, we write Java main, and then we pass the argument. Could be anything, like name, any name. So I use my new key. Okay. Shall we continue? Right. So let's say we want to use certain standards, right? So we want to define the usage. So how do we? Because as you see, there are questions on how we generate the key. So I think it's better to use comments to explain how we generate the keys. So I say key file. So this generates key for encryption. And now, so we want to take further our project further and want to introduce encryption and decryption functionality. So for encryption, because we want to use the same class for encryption, decryption, and key generation, I'd like to introduce another argument called I will use gen key for key generation, and I'll use encrypts for encryption. So for key generation, we have Java main, and we use this first argument and then second argument. First argument defines that, oh, we're actually trying to generate key, and here's the key file. Please use this file to house the symmetric key, right? And when we're ready for encryption, we use encrypt, and then we pass plain text data, and then plain text data is stored somewhere, and we want encrypted data to be stored in encrypted file. So this is used for encrypt file, encrypts data. Okay, and in the same way, so you want okay, copy and paste. You want decrypt. This time decrypts data, right? But this time when we use decrypt option, so we want to take this encrypted and pass it encrypted, and then pass it encrypt and pass it to the pass it as a argument, and store the decrypted data in the decrypted file, a file called decrypted. Okay, so this is how we want to use our our project, our program. So first, we need to define. We need to, because this option now contains the mode of the program: generate key, encrypt, or decrypt. So we need to check if arguments for if the first argument equals chain key, right? If it's equals chain key, and then we generate the key. Okay, right? If anything else, then we do encryption. So in this case, we generate key. Here we do either encryption or decryption, depending on what we pass here, encrypt or decrypt. Okay. So depending on what we passed, right? So it depends on what mode we are using. So for to define the mode, just I create an integer mode, and I check if args if the first argument equals encrypt, right? Then if it's encrypt, then I need to define the mode. Go to cipher, encrypt mode, else decrypt. Oops. So this is how I define the mode, right? Okay. Right. Let me check the comment section. Okay. So here I'm defining the here the mode, right? So else decrypt. So okay. So we created a possibility to encrypt and decrypt by passing encrypt or decrypt option in our program, right? And now we actually need to perform the encryption and decryption. So first of all, I need to read the key which we generated, right? So when we generate the key using gen key option, so we're, as you see, we're writing it to the file system now. In when we're encrypting the data, we need to read that read that key. Um, Key comes in. So to read, we need to again use. I'm gonna use object output stream, but this time because we're reading the key, it could be input stream. Um, and we have a file input stream, and it comes as the it comes as a third argument. Uh, 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 so why I'm using 3, because here we forgot to mention key file here. So to encrypt, so we know how to generate the key, right? So we use this, we pass this gen key and then key file. But for encryption, we need, now this time we need to specify encrypt option and then pass plain text encrypted plain text file, encrypted file, file name, and then key file name. So that's why we're accessing it in the third, as part of third argument. And we also have, so this is for key file, okay? And now we need to access the input stream, because we start to read the file from file system. So we use file input stream for input stream, and we're gonna have args 1, right? Because zeros, we already we use zeros now to define the mode of the program, generate key encryption or decryption, right? And now for first argument, we define either in the case of encryption, it will be plain text or encrypted in the case of decryption. And out, incoming data, meaning outgoing data, right? New file input stream, args2. So anything first, anything comes after encryption, decryption could be, will be incoming data, and this is outgoing data. For in the case of encryption, incoming data will be plain text, and outgoing will be encrypted data, right? And when we decrypt, incoming data would be encrypted information, and outgoing data would be decrypted information. So and we need to and now we need to read the, because we need to actually read our key, so because we read it as object input stream, right? And So when we try to access it, so we read object, and then read object returns as an object. We need to cast it to key because we're gonna use this as a because we need to cast it to key to be able to access the methods that key provides us. Okay. Now we need to create an instance of Cypher. Right? Cypher. Not really sure why IntelliSense is not working. Usually it should work, meaning like it should give us the Intel, meaning like hints, right? It's not giving us hints for some reason. Yeah, it's not important. So cipher. So we need to specify what cipher we're going to use. So we're using AES, right? Just like here to generate the key, we specified we're using AES. First, again, similarly for cipher, we use AES, and we need to initialize our cipher just like we initialized our key. And we define the mode here, meaning if we are doing encryption or decryption, right? And we pass our key here. And the heavy lifting will be done using utility file, which I'm gonna create now. So let's say we have util crypt, util class and crypt method, and we're gonna pass whatever incoming file, and then we do encryption and write it to outgoing file using cipher object. So cipher defines the algorithm. In this case, we're using AES as an algorithm. Okay. So I'm going to create a util util file. I have my util file here, pre-written. Okay. I'm gonna just copy and paste here. Public util. So this is basically a static method. So I'm not gonna focus much on this because this basically explains how cipher works. Because cipher encrypts data based on blocks, right? So depending on block size. So here we're using just getting the block size from the cipher and defining the and doing encryption or decryption based on those block sizes. So depending on, so we create like array of bytes, that and how many bytes, that many block size bytes. Okay. um, so this is a bit low level encryption um, uh, functionalities here, so we don't have to worry too much about it. What we need is what we need to make sure is that our main class works correctly. Um, so let's before we actually run our class, I wanted to check the comments. Yes, yeah, we need to create util.java because this is where um, uh, the boilerplate code is located. This code is basically helping us to with encryption and decryption by taking the input and dividing it into blocks, and then passing those blocks to AES algorithm, so algorithm can do it block by block. So where do we get the boilerplate code? Yeah, I can send you the boilerplate code later once the session is over, just to save time. I will just skip it for now. And after the session, I'll email you, maybe share it on Discord if that is okay. Let's check if we can actually run our program here. Java C util Java. Cannot find symbol. Okay. Yes, because we didn't import. So what do we import here? Import Java IO, because we're using yeah, output and input streams, and we import Java security, and we also import Java extension package, crypto. Yeah, let's try to compile our utility class. Hopefully it compiles. Yes, it compiles. And now let's compile our main class. Okay, incompatible types cannot be converted to output stream. Okay, 39. Okay, yeah, I think I should have make it output, not input, output stream, right? Let's check. Let's try again. Okay. looks good. So Java main. So inside main, we say we generate key, gen key, right? And key file. So we define the key file. New my key, right? Okay. So let's see. It produced something different. It's not the key. Okay. I think I should change it to 1 because it's just taking the wrong name. Let's compile once again. And remove these and delete. Let's delete. Delete. Okay. Creating brand new key. Okay. Called my key. Let's see my key. Okay, it's created, and yeah, we have key. And now let's try to encrypt. Do we? Let's. So we can create like a plain text file. Text. Yeah. Okay. I think Replit needs to install something before we can use the. Let me. Okay. Search. Hello, my friends. Right. This is the message we're gonna. We're gonna encrypt and also decrypt later. So okay, my key. Instead of chain key, now we use encrypt. And encrypt what? Plain text. Encrypted text using my key, right? So let's try. Encrypted text. As you see, it produced encrypted text. It's not readable, which is what we want, right? And now let's try to decrypt it. So we change the mode to decrypt, right? So decrypt, and what we pass as an input, we pass incoming file would be encrypted text, and produce in output in decrypted text using my key, decrypted text. Okay, let's see if it works. Decrypted text. Yeah, so it decrypted successfully. Hello, my friends. Okay. Yeah, this is basically how we did. Yeah, our utility program works. So this is boilerplate code. As I'll share this one with you after this session. One thing I need to mention is that when the data is split into blocks, some data may not, the very last block that needs to be handled in a special way, because those blocks may not be full. The very last block may not be full. That's why that needs to be padded with some characters to be able to encrypt and decrypt successfully. So when we do this, so cipher that we are using, it helps us with this padding. So it uses do final method where all this padding happens. Okay, because we want data to be split evenly into blocks, and when the very last block does not have enough data to fill, so we pad the data with certain characters. So this do final method does this padding for us for free. Okay. Okay. Right. Yeah, so that was private key encryption. So again, let me go back and reiterate what we did. So we followed this approach. Okay, so we had plain text data which we created, right? So this plain text is here. Plain text is here, something readable, meaningful, right, for us and for machines. Let me close this, and we used shared key to generate ciphered data, meaning encrypted data here, right? So we have encrypted text here. You see, it's not readable, like it's basically gibberish. We cannot really read and understand what it means. And we created this encrypted file using key, which is also not legible. So we covered this part, right? And then when it comes to decrypting the data, so we took the same encrypted text and the same key and decrypted it using the same key, right? So when we decrypted, what we received is the decrypted text, hello my friends, which is exact same text as this one, plain, in the plain text, hello my friends. Okay, so this basically wraps up our session. This is what we did today. We understood, we've covered two main types of encryption used in computing. Private key encryption, where single key is used to both encryption and decryption. Also, we've looked at public key encryption, where two keys are used for encrypting and decrypting. One is for encryption and other is for decryption. So now we have two methods of encryption, right? Let's say question for the audience. Uh, Before I ask my question, I answer question in the chat. So center dev asks, so for decrypting, we need the same key that was used for encrypting. Correct, yes. Because it's shared key or private key encryption, right? The same key is shared for encrypting and decrypting. So my question is, let's assume we have a book, right, which has 1,000 pages, right, and we want to encrypt it. So we want to encrypt it, right? So we have a book with 1,000 pages. So do we use private key encryption or public key encryption? Private key meaning private key encryption being AES, DES, and etc. or public key encryption, RSA. Which one do we use? Which one do you think we should use? Option 1 or option 2? Any guesses? What do you think? If you want to encrypt contents of book which has 1,000 pages, is it option 1 or option 2? Okay, private key. Option 1. Why do we need? Why do we use option 1? Why do we need to use? Why not option 2? Yeah, I think there's a good answer here. RSA would be inefficient and costly. I agree, because RSA, being public key encryption, it uses prime factorization, and while it may be really fast algorithm for small chunk of data, but book with 1,000 pages and using public key encryption for it, it could be very mathematically, computationally expensive, and that would be really inefficient way to encrypt 1,000 pages of book with RSA. So we go with private key encryption because it's much faster. It doesn't use prime factorization as public key encryption uses. So yeah, option 1 would be way to go. Yeah. So what is XOR? So XOR basically means it's a bitwise operation. So there are many such operations like AND, OR, XOR, or negation. So XOR, so it's exclusive. The OR we use on daily basis, it's mostly inclusive OR, right? If both operators are, for example, true, or either is true, then final result will be true. Yeah, that's yeah. Yeah, XOR uses this rule, which our user just explained in the chat. Yeah, bitwise operation. Again, bitwise operations are very fast because AES and DS, private key encryption, what they do is just they take the data and then they convert the data into bits, and work in on bits level. It's very, very fast. So so bit those operations would be OR operation or exclusive OR operation, where we just mentioned. That's where uh, uh, the uh, that's where the speed of the private key encryption comes from, because they operate on bit level, right? But public key encryption, they use prime factorization, which is computationally expensive, very, very expensive to compute. Yeah, for large amount of data, option one is way to go. Yeah. Okay. At this point, I would like to wrap things up, and hopefully you enjoyed the session. It was I wanted to cover public key encryption as well in detail, but time flew very fast. Yeah, thank you everyone for coming and joining. I enjoyed uh, taking questions from you and answering them, and yeah, enjoy rest of your day or night, and hopefully you will attend other sessions this week, and I will share my source code on Discord, and yeah, thanks for coming, and I'll see you next time. Have a good one.